Welcome to day 11, everyone, for the Advent of Code 2019 as we continue to try and solve all of this year's problems. Today's problem is revisiting our Code program. Basically, we have a little robot now that needs to paint our spaceship, and we are going to be running the program here, so I can actually run it because I've set it all up, and we will be giving it inputs, and it'll be outputting two numbers. The first number is the value indicating the color to paint the panel that the robot is at. So if it outputs a 0, that means it's painting it black. If it outputs a 1, that means to paint it white. And then the second value is the direction it should turn. 0 means it's turning left 90 degrees, and 1 means it's turning right 90 degrees. And then whenever it turns, it always moves forward one panel. Yeah. What we have to do is we need to keep track of how many panels the robot has painted. Specifically, how many panels it's changed the color of is the biggest thing. So as the robot goes along, we need to keep track of the panels it's painted, what color they are, and then we need to input the number of panels it paints at least once. So we already have the program running here, so what we need to do is utilize this print out instead of just printing the line to also track via lambda here. So this is going to be out, and then the system out print line of out. We also should do this. So when we output, we need to know which output it is. So first we need a private boolean. Let's just call this color output. Start at true. And then every time this runs, we will set it equal to the opposite of it. And what we will do here is check it. So if it's the color output, we will do one set of logic. If it's not the color logic, we'll do another set of logic. So along with this, we need another class. This is going to be similar to what we did on day 10, which I'll actually just go and copy because I'm lazy. Is this vector2i, and actually we're going to just copy this whole thing. I'm not going to need all these methods. I'm not going to need hash code. I'll leave hash code there in case we do. We're not going to need distance too. So we have this vector2i. This is going to be our current location. Current location. Vector2i started at 0, 0. And actually what we're going to do is we're going to do a map. So we do need that hash code. A map of vector2i's and then an integer to represent the color of the panel. It's hash map. Okay. Import all that. All right. So if we are outputting the color, what we should do is take colors. Compute if absent, give it the current location. If it's absent, I'll put 0 or give it 0, because that's the default value. Actually, hold on. So we don't want to change the color, but we want to. So we want to get the color. So int color at panel equals that. So if the color, and what we'll do is we'll keep an integer int panels painted, and actually we only care, do we only care if the panel was painted? So we don't need this map then, because we don't care if it's been painted twice. So never mind, we don't need a map. We just need a list Oh, but we do need to know if it's been painted. So I guess instead of integer, it's going to be a Boolean. Oops. It's going to be a Boolean instead. And we're going to say false. And this is going to be painted. But do we need the... Well, they all start as... Do they all start as black? So I guess they don't tend to... They could all not be black. Huh. How do we want to deal with this? This is painted, of course. You know what we can do? We can do integer. And we can store the color there, or if it's been painted, just set it equal to 3. So by default, it is going to be out, will be the color that goes there. Convert that to an integer. Okay, so again, so this is going to be color at panel. So if color at panel equals 3, or if it does not equal 3, because 3 represents it's been painted. So if it does not equal 3, we will check if the color at the panel, so int current panel color. So we're going to set current panel color equal to, let's just do that. Set that as the input. So if current panel color does not equal that, what we will do is then do colors dot put the current location. And actually, let's condense this down a little bit, make this one if statement instead of 2. And then we will also set that we have painted the panel. We can't increment this, so we got to do a little trick here to make this an integer array. Again, one of the downsides of how I designed this to work is that unfortunately we have to do like tricks like this to be able to change variables and whatnot. But anyways, so that will count up how many panels has been painted. Next, what we need to do is using this direction, we need to implement the robot moving, so changing the current position. So we also will need an enum here. So this is going to be public enum direction north, south, east, and west. Okay, and then what we need to do is do public void move in direction, or turn in direction. Turn in direction. Provide it to direction. And then, oh, we needed, but it needs to know the current facing direction. So let's actually change this. So let's do public direction. So it's going to take in a vector 2i. So this is going to be change. And then it's going to take in a direction left and a direction right. This is going to simplify our logic a bit. So north is going to be new vector 2i. We'll make this 0, 1. That's fine. And it's going to take in Left is east, right is west, and the rest of these will need this. Whoops. Okay. So south, left is west, right is east. For facing east, left is south, right is north. Oh, can you not do this? Oh, it's got forward referencing. Oh, we can't do that. What if instead of it being a direction, let's do a vector? No, never mind. I'm trying to, no. Never mind. Let's just do a method here instead. Public static direction. Let's just call this turn for direction. We'll provide it a boolean for right. So the boolean will be turn right. So if, let's do a switch statement on the current direction. Case north. If we are turning right, that means we need to do, oh, we also need the direction, we need the vector, the current position. So if we are turning right, the current position will be incremented on the x. So current position dot x plus plus, and then return. If we're turning right, return east. Else, the F. On the other hand, I didn't do that. On the other hand, if we are turning left, decrement the x and return west. There we go. Sorry, I was right. Okay. So here's north. Let's do east. So if we're turning right, we'll be facing south. Otherwise, we'll be facing north. If we're facing south, we want to decrement the y, increment the y the other way. Here is south. South will be turning west. East, it's actually just the flip of these. And then lastly, for west, if we turn right, we'll be facing north, where we increment our y. Otherwise, decrement the y, and we're facing south. Okay, so now we have this method here. So what we can do here is we can actually just straight up call, we need a direction, so private direction current direction equals direction dot north. Because it starts off facing north is what the problem gives us. What we actually can do is we just do current direction equals current direction turn for direction current location, and we need to know which way it's turning, and this is going to be the output, so it's just going to be output equals 0, because 0 means left, so no, it's equals 1. So if output is 1, that means we're turning right, so that gives that a true value. Otherwise, you turn left, and that actually will work. Am I missing anything? Otherwise, return there we go. Okay, so we don't, okay, we do need that. So After all that's done, we can just do a system out print line, panels painted 0. This is part 1. Let's see how far off we were from the answer. Okay, so give this a run. So I believe what we do is we input 0 because it's black to start. That means it's a 1 underneath. It's now moved. I don't know what's underneath now. Oh, we need to know where we're at. I gotcha. So the input, so the very first input is ours. Otherwise, actually no, there's no input. We just give it. We don't need to give our input. We just feed the input directly in. Okay. I see. So we need to edit this to simply input not a scanner, but input what is actually there. So we don't need this. So the panel color is 0. Okay. So this is what is there. Okay, so we don't need this. This can go away. We can put this in here because this will be set equal to colors dot get current location. There we go. And what we can do, at is not current panel, or sorry, current panel is less than or equal to 2. So we're gonna do 3 and 4. So 3 is black and it's been painted black. 4 is white, been painted white. Okay. So we're gonna do colors, put color at panel +2. And that's it. All right. So what then that means is we do on the set inputs. That means we don't need this here. This part can go up here. And color at panel can be simply equal to colors dot get the current location. So this will handle the initial setting of it. So compute fast, so if absent, it's 0. Otherwise, we also need to check if color at panel is greater than 2, because if it is, we need to minus equal it by 2. And then we set the input as that. All right, fingers crossed, this will automatically do it for us. I'll leave the output just to make sure it's running. Okay, so it is running. But of course, it just says 0. Good. Oh, it's less than 2. Oh, it's greater than 1. Oh, I messed up on that. Let's try that again. No, again? Well, that's going to be the same. Oh, because we're not using out. That's why. Current. So we're going to use current panel color. So current panel color, current panel color, current panel color. Okay. Try that. So now we're using the current panel color 11. I doubt it painted 11, but no. Wait. Why is our input always 0? Ah, because we need to do out +2, not the panel color +2. Ha ha ha, that's where issue is. 87 sounds better to me. But it's still not right. We have to make sure we are always changing the color though. That's a big thing. We always have to make sure that we are changing the color. That could have been the issue. Ah, that's a much higher number. Hey, there we go. So that was the issue. We didn't update the colors even if it changed the color. Okay, so let's clean this up. Remove all this excess printing. Run this again, make sure we still get 252. Okay, there we go. So there's part 1 done. Let me read part 2 and I'll get back to you guys. Okay, so part 2 is instead of starting the robot on a black panel, we need to start him on a white panel. That's actually easy enough to do. All we do is we actually go to colors, and before we start running it, we do colors dot put new vector, or we put current location, and we just add a 1 there. So that will start it off on a white color or a white panel instead of a black. And then the other bit is we need to now know what is it outputting. So what did it decide to paint on our side of our ship? The registrations are 8 capital letters, or sorry, what the robot's painting on our ship is a valid registration. And it says that there are 8 capital letters. So to see what it's painting, let's sort this. Let's do a list of vector 2i's. This is going to be the sorted list, or sorted positions, equal to new array list. Give it the colors map key sets. So this is going to be all of the visited places on the map. And we will do then arrays. So no, it's just sort, and it's gonna be new comparator. So when we're comparing these, we will return, so if o1 dot y is greater than o2 dot y, return this. I think it's that. Else return this, but for the x's. This way, it'll do the y's first and then the x's. And let me then do system out print line. You'll see what I'm going for, because I'm going to try and output what it's painting into the console here. And to do that, we need to start it at 0, 0, do lines at a time, and then finish. So we need to have it be a full line. We need to have all the y's in a row first, and then all of the x's sorted. So that's how I'm sorting it like this, just so I can output it to the console. So it's going to be sorted positions dot to array new vector 2i 0, and we can make this a lambda. Fine. Run this. Let's see. -4 is the largest, or is the earliest? Wait, they're all -4. They're all the same location. You know what? It's because I'm adding the same exact one to the list. Okay. Actually, what if we just do string? What if we do that instead? What if we just convert it to the string value? Because the string value will correctly hash. It'll correctly hash the string values. This is going to be a string. That's the only difference, is this is going to be a string, but whatever. I don't think I could sort that, but I guess I technically could. 101. Okay, so now we just need to sort this. So we need to do int x equals o1 dot substring from 1 so it's integer parse int substring from 1 to o1 dot index of the comma. This is really inefficient, but this is gonna work well enough, I guess. And the y is going to equal o1. Oh, this is o1x, o1 or o2x. Let's do this o2, 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 and then do this again. But this is going to be o1y, the y, o1, so it's going to be index of that plus 1 to the o1 dot index of the ending bit here. Copy this, paste it here, change this to o2, o2, and now we have our bits, so we can just do o1y, o1y, o2y, and then o1x and o2x. And please sort correctly now. I don't need that. Okay. Oh, I think I know what's happening. It's just we need to do... Okay, and then all we do is we just compare them here and compare them here, but this is going to be the y's. So let me go ahead and now run this. How does it? I also know the part 1 because the part 1 changed because I did something different. What is? I'll leave the part 1, it's fine. Comparison method validates its general contract. Actually, no, I'll comment it out. Actually, we can just do. Actually. Oh, it's not greater than, it's just not equal. It's just if they're not equal. That's what we're supposed to do. My bad. That's where the issue came in. Okay. So it's going to sort the y's first. -5 up to 0. Okay, so we actually do want it to reverse, so I do want that. So I want 0 to be the top, -5 to be the bottom. Okay, and that looks to be increasing correctly. Okay, so I think we've got it right. So let me get my... Let me get a block character from Unicode real quick. Where's the full block? Full block. Okay. So what we're gonna do is we're gonna go for we're gonna do int current y. So for vector to I, vector in was it sorted positions, system.out.println. Do that. Okay. Oh, string, sorry, string. And so what we're gonna do is we're gonna do an if colors dot get vec modulus 2 equals 1, because 1 is black, right? Oh no, 1's white. So that's right, okay. Else output just a blank space, because this will be black down here. And then do an if check here. Actually, sorry, the if check go first. So if I need the y value. Oops. I need the y value, so I need to check what the current y is. So if current y does not equal y, current y equals y, and we also then need to just to do a print line, because these are actually all just prints, and the print line is how we're going to skip to a new line. That's how we're going to drop down, and I think now we're good to go ahead and run this. You know, that actually worked pretty well. Honestly, I can almost read that. A few lines are awkwardly offset. Yeah, I can't read it because they're not the same. Really, that's really weird. Oh, it's probably because they have different X's. Ah. Okay. So what I do need to do is I need to hold the lowest X. So I do need to find the smallest X. So int smallest X integer dot min value. So here's all the X's. So if smallest X is greater than X, smallest X equals X. Oh yeah, this is max value, my bad. There we go. And so then what we do here is we do if X is current Y, we print a line to go to the next line, and then while X is greater than smallest X, print out a dot, or we don't need a dot, just print out a space, and we can do X minus minus. Let's try that. Will that work? Oh. Not quite. Why did that not seem right? Oh, because we're not doing the X, we're doing the Y here. I need to parse the X, not the Y. The smallest X is -5. Also, we need this up here. My bad. Smallest X is 0. Okay, that will work. Put this back. Remove that. Remove this. While X is greater than smallest X, X plus plus, or X minus minus, and then also print out a blank line. Sorry, I forgot about the blank line stuff. Hey, there we go. That was interesting, all just to get this to look nice. The things I do. Okay, so we don't need that anymore. Okay, anyways, so let's put this as our input. Let's verify that we got it right. So it's AGALRGJE. Submit. Got it right. Gold star. That is day 11. Done and in the books. So, hopefully you guys enjoyed. I will be back tomorrow for day 12. So until then, peace out.